purpose of this screencast is to demonstrate the functionality of the TI-Nspire CX calculator and applied to some of Kirk Weiler's eMathInstruction Algebra I problems. This problem is based upon Unit 8 and Lesson 1. So let's start the problem and start working with the calculator. It says consider the quadratic function y equals x squared minus 2x minus 8. Using your calculator to help you generate a table, graph this parabola on the grid given. Show a table of values that you can use to create the plot. Okay, so we're going to go over to our calculator now, and I'm going to go right to the graphing function. I notice this window does not look like the window that we have on the other one, so I'm just going to set this up, and I'm going to give you a few caveats regarding some of the labels on these windows. So we're going to go to Windows Setting. Okay, my x values look good. I'm going to force it to have increments of 1. And then I'm going to go to my y scale, and we'll have negative 10 and 10. And we'll force that once again to go in increments of 1. I'm going to click OK. All right. Note that negative 10 there, I'm going to count negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Negative 10 is referring to that very last tick mark that's at the edge of the page here. All right, and same with my negative 10 here, that refers to that tick mark. So be careful with that. I also sometimes like to show a grid, and I'll show you how to do that. We'll hit the menu, we'll hit View, and we'll go down to Grid, and we'll do a line grid. There we go. Okay, now we want to type in our function. We don't have to go to a y equals key. We don't have that on the TI-Nspire CX. It's right there in the graphing portion of this. So we'll enter our values. X squared minus 2x minus 8. And we'll hit our enter key. And there's our graph. Okay. Now, in order to plot the graph, we're going to have to look at a table of values. And we have a really nice feature in this calculator that allows us to look at the graph and the values. So we'll go to Table, Split Screen, and there we go. So we can use these values. We might want to scroll over to something reasonable. Negative 3, 7 would be an ordered pair we could use. Negative 2, 0. Negative 1, negative 5, etc. Okay, so using those to create your plots. We want to know the range of the function. The range is the the y value rather. So I'm going to go and find my minimum value is negative 9. So the answer for the range would be y is greater than or equal to negative 9. The domain in which it's increasing. Let's go back to the table. So I see that I am decreasing when I go from negative 1 for x to 0, but I start increasing when I go from negative 1 to 2, where I get negative 9 and negative 10. So it's increasing. The domain interval of the increase is x is greater than 9. State the coordinates of the turning point. Also known as the vertex and its minimum point. Okay, let's get rid of this, and we're going to show you some more tools. So we go to Menu, Table, Remove, and there we go, back to our other view. Now, Menu, Analyze Graph, find the minimum. Okay, we got these lower and upper bound things. Should look familiar if you use a TI-84. Just click and click. And there's our values. So our value for the turning point, or the vertex, is 1, negative 9. Axis of symmetry. Well, we know that axis of symmetry is going to go through that vertex. So we would draw a line that goes right along the value of x equals 1. Next, we want to find the x-intercepts. These are known as the function zeros. It makes sense because that's where it intersects the x-axis, and that means the y value is 0. So again, what do? Go to Analyze Graph, hit 0. Okay, I'm going to go minimum or lower bound, upper bound, and there's my 0. It's -2, 0. I want to find the other one. Hit menu again, Analyze Graph, and hit the 0, and get a lower bound, upper bound, and there's our value, 4, 0.